Hello and welcome to today's lesson, a review of mean value confidence intervals. So we're not going to work through full problems here. We're going to be looking at what steps do you need to complete and get full AP credit for a mean value confidence interval problem. So the first thing we want to do when we look at the problems, number one, you have to be told to do a confidence interval. Okay, if the problem does not state complete a 90% confidence interval for this situation or an 80% confidence interval for this situation, you do not want to do a confidence interval. You would instead do a significance test or a hypothesis test, which we'll look at in the next video. But as you're looking at the problem, first thing you want to do is read through the problem, pull out all of your mean and standard deviation calculations. And the big thing that we're looking for here is we're looking for the fact that it's a sample standard deviation where they might denote it with an S of X term. Okay, so we're looking for mean value problems based on sample standard deviations. Okay, and that tells us that we're actually doing a T interval because the standard deviation of the population is unknown. And then the next thing that you have to do, once you found your values, you pulled that information out, you want to make sure that you state what type of interval you're doing. Are you doing a one sample because you have one mean, one standard deviation, or are you doing a two sample T interval? Okay, so you always like your null and alternative hypothesis, okay, the type of that test. Here you have to make sure you tell the person what type of interval you're doing because they're going to grade you based on the steps that are required for that type of interval. Okay, once we pulled out our values and decided what type of interval we're doing, one sample or two sample, the next thing that we have to do is verify assumptions. And assumptions really don't change no matter what type of problem you're doing. You're always having to prove, is it a random assignment? Do I have independent values? And how do I know that my distribution is a normally distributed sampling distribution? Okay, random is one of the easiest ones. You have to be told in the problem that this information comes from a simple random sample or a random sample. Okay, and you want to do that is you just want to state that sentence. Random sample of blank stated in problem. Okay. Independent is always a calculation. Our independent calculation here is 10 times our sample size. Is that less than the population? And the reason why we do this calculation is we don't want our samples to be too large. We don't want our samples to be more than 10% of the population. Because then if they are, one sample would affect the other sample, and we wouldn't have separate independent samples. So we want the sample no more than 10% of the population. Okay, normal distribution. Okay, there are three ways to know whether we're dealing with a normally distributed sampling distribution. Okay, first method is you're told in the problem. And just like with the simple random sample or random sample, you would just copy that sentence. Normal distributed blank stated in problem. Okay, the other method, okay, if we move up from least difficult to most difficult, is based on sample size. And our general rule for sample size is n greater than 30. Okay, so if our sample size is greater than 30, we can use the central limit theorem to assume normality. And then the last method, the most difficult based on situation, if your sample size is under 30, you're not told that it's normal in the problem, you have to graph your data. And the graph that we're usually looking for is a box and whisker. And we're looking for outliers or skew. Okay, so if there are no outliers or extreme skew, then it is normal. Okay, and you have to show a sketch of the box and whisker. Okay, you need to show that. Okay, based on a box and whisker plot of our original data, there is no outliers or extreme skew, so we can assume that it's normal. Okay, this is always worth 1 point out of 4 when you're doing a confidence interval, when you're doing a hypothesis test. Okay, stuff that we can memorize, stuff that we can make very easily to plug in and get that point overall. Okay, and what you want to remember is if it's a 2-sample problem, you have to run your assumptions for both samples. Okay, so you would have a column for the one group, column for the other group, verify all your values. Okay, and we're always looking for, is it random? Do we have independent samples? And is our sampling distribution normal? Okay, calculations. The one thing that you want to remember is the formula sheet houses all of the calculations that we're looking for. So I've cut some of them out here, but I want to show you as well. Okay, the formula sheet that you're given. Okay, this is going to be given to you for the test. Okay, and if you go over to the back side, this is all of our inferential stats or hypothesis test confidence intervals. Okay, you're given the confidence interval formula. Okay, if it's a single sample, sample mean, here's our standard deviation of the statistic, also known as standard error. Okay, and then if you have a 2-sample, difference of sample means. Okay, we can pull those pieces out. So everything that we need is on this page. We just have to be able to plug the values in as we're working through those calculations. So you've got your X bar plus or minus T star, and we'll talk about T star here in a second. Okay, but we can tell since we have one X bar, it is a single sample mean situation. So then we need to plug in the standard deviation of the statistic, S of X over square root of N. Okay, and we're just plugging in the values. Okay, you'll be given X. You'll be given S of X. You'll be given N. And all we have to do is look up T in a table, and we have everything that we need. Okay, not much difference in the 2-sample. You know, once again, it's going to stand out as a 2-sample because of the information that you're given early on. And then all we're doing is looking for the 2-sample difference of sample means. And then we have our formula that we're going to copy over into the interval. Okay, 2 sample sizes, 2 standard deviations, okay, plugging through all of those pieces. Now, when we're finding our T star, Okay, T star is based on your degrees of freedom. And the easiest way to do degrees of freedom is sample size minus 1. If you're working with a 2-sample situation, you just use the smallest sample size minus 1. Okay, it gives us more room for error when we jump into our t-table. Okay, so when we're in the t-table here, okay, remember how we read this? We want to look at the bottom first to find what column we're working in. So let's say we want a 90% confidence interval. Okay, now we know that we're working in this column. And then the degrees of freedom, sample size of 12 would give us degrees of freedom 11. And then all we're doing is being careful to make sure we line up and find our T star value. Okay, it's a lot quicker to use the table than it is to use the graphing calculator. Okay, so definitely use the table in that situation. If you're dealing with a Z problem, remember, the Z value is just listed at the bottom. The rest of the table is T values. And then finally, once we've done our calculations, then we move on to the conclusion. Our conclusion needs 3 things. Your confidence level, that's going to be stated in the problem, or you pick your own. The interval you created, and the context. Okay, now the important part about the context is use the terminology from your formula sheet. Talk about the sample means or the difference of sample means. So now when we're writing it, it is just a cookie cutter. We are blank % confident that the true sample mean or difference of means of whatever the context is, okay, so the true mean value or difference of mean values are between lower boundary and upper boundary. And you're just plugging in those values to fill out that situation. Okay, now for your in-class packet, okay, we're going through doing a little bit of review. Okay, in this packet, there's multiple problems. In problems 1 and 3, you're going to work with the confidence interval portions of those problems. So you're going to have 1 1-sample and 1 2-sample situations. Thank you and have a good day.